Welcome to our video solution for problem 3 from Superquiz 1. In this video, we're trying to find the domain of a function of two variables. So the function here is a fractional function. So on the numerator, we have the root of 2 pi minus y, and in the denominator, we have the cosine of x. So in order to find the domain, we need to figure out which values of x and y can be put in so as not to break this function. So if we look in the numerator, we see we have a square root, and square roots automatically tell you, yeah, you can't put in negative values. So for the domain, we're going to need that 2 pi minus y is at least 0. Of course, it's equaling 0 is okay, right? Square root of 0 is 0, but you can't put in negative values. So this is equivalent, let's add y to both sides, to saying that 2 pi is greater than or equal to y. So if we were trying to sketch this, we would right off the bat say, well, okay, the y value can't go above 2 pi. So let's put 2 pi right there. It can be equal to it, so we're going to use a solid line. But, excuse me, I know I can't get anything above that, so the black will be used to exclude things. All right, so that'll handle the numerator. What about the denominator? For the denominator, well, we can't let cosine of x be 0, right? Cosine of x has to not be 0. Well, when does the cosine equal 0? Well, let's draw another little picture. Let's draw our unit circle. We know that the cosine is the x-coordinate of a point on the unit circle. So if we want the x-coordinate to be 0, we either have to be up here at the top or down here at the bottom. All right, both of these, right? So this has coordinate 0, comma, -1. This has coordinate 0, comma, +1. All right, so we just need to identify what angles we're at when we get to either the top or the bottom. So if you started from 0, this would be up here at pi over 2. Okay, and then you'd have to keep traveling around and you'd get to 3 pi over 2, which, just for fun, let's write that as pi over 2 plus pi, right? That's how far away it is. And then if I add another pi from 3 pi over 2, I'd get up here, I'd get 5 pi over 2. Okay, so I can keep on adding pi radians, and I'll get another point where the cosine is equal to 0. On the other hand, if I'd started and gone backward, I also could have gotten negative pi over 2, and that'd be another position where the cosine is 0, and I could keep subtracting pi. So in total, I can start from pi over 2 and either add pi to keep going around in the counterclockwise direction, or subtract pi, go around in the clockwise direction. So cosine of x equals 0 when x is equal to pi over 2 plus some number of copies of pi, where this number here is some integer number, right? So where k is an integer. Okay, so we would say, we'd call this an integer multiple of pi. So what we have to do in the graph here is write down all these integer multiples of pi plus pi over 2. And of course we can do this on the negative side as well. Negative 3 pi over 2, negative 5 pi over 2. And at all these positions, right, the cosine of x would be 0, so we're not allowed to have those x's. So we have to toss those out. Again, I'll do that in black. Okay, this is certainly not evenly spaced, but hopefully you get the idea. So we cannot have points that lie on these dotted black lines. And so the domain would end up being, right, all this stuff below y equals 2 pi, or equal to, and lying in between these dashed lines. Okay, from a set builder notation point of view, we would have that the domain equals all pairs x comma y, where the y is less than or equal to 2 pi, and the x is not equal to pi over 2 plus k pi, where k is an integer. Or if you're a math major, you should learn to write this as k is an element of the set of integers. All right, and there is our domain.